class, this is lesson 8.4, and in this lesson we're going to study the properties of a rhombus, rectangles, and squares. So first of all, we're going to start with our rhombus corollary. So it says a quadrilateral is a rhombus if and only if it has 4 congruent sides. So to be a rhombus, all 4 of our sides must be congruent. So ABCD is a rhombus if and only if segment AB is congruent to segment BC, is congruent to segment CD, is congruent to segment AD. So all 4 sides must be congruent for it to be a rhombus. The rectangle corollary says a quadrilateral is a rectangle if and only if it has 4 right angles. So ABCD is a rectangle if and only if angle A, angle B, angle C, and angle D are all right angles. Our square corollary says a quadrilateral is a square if and only if it is a rhombus, so all sides are congruent, and a rectangle, so all angles are congruent. So ABCD is a square if and only if segment AB is congruent to segment BC, is congruent to segment CD, is congruent to segment AD, and angle A, angle B, angle C, and angle D are right angles. Which you already knew what made up a square, but oh, I spelled the word rhombus wrong. R-O-M-B-U-S. You already know that for a square, it's got all right angles, all 4 sides congruent, but the rhombus part might be the newer piece here. So let's just draw a little Venn diagram to help us with this and help us see where everything is being placed here. So we have a bunch of different shapes that are all parallelograms, which we talked about in 8.2 and 8.3. Okay, so here's my Venn diagram with a bunch of shapes that are all parallelograms. Some of them look like this, some of them look like this. Okay, so we have a bunch of different parallelograms. That's not a very good one. There we go. So inside parallelograms, we have 2 separate categories, and they do overlap. So one of them is rhombus, rhombuses, kind of a funny word, but rhombuses have 4 congruent sides. So not all parallelograms are rhombuses, but some of them are. And then we have another group over here, and those are rectangles. And they have 4 right angles. And if you notice, I drew this so they're overlapping because in the middle we've got this small group that's both of them. And that small group, those are our squares. Oh, it didn't fit quite in there. But this small group in here, those are our squares. Okay? So squares are parallelograms, they're rhombuses, they're rectangles. Rhombuses are parallelograms, but they're sometimes squares. Rectangles are parallelograms, but they're sometimes squares. Down here at the bottom, it says for any rhombus, RSTV. So let's just draw a rhombus, RSTV. Okay? And with it being a rhombus, I know that I can mark all 4 of my sides are congruent. Decide whether the statement is always or sometimes true. Draw a sketch and explain your reasoning. So I'll put my angles RSTV. So this says angle S is congruent to angle V. So angle S is over here, angle V is across from it. Now let's look up here. We know it's a rhombus. Since it's a rhombus, it's also a parallelogram. And with parallelograms, opposite angles are congruent. So this, what they just told us, is always true. And that's because with a parallelogram, and a rhombus, opposite angles are congruent. So because it's a rhombus, it's also a parallelogram, And because it's a parallelogram, opposite angles are congruent. So let's look at the next one here. It says angle T is congruent to angle V. So let's look here. Angle T is congruent to angle V. Now these are next to each other. With a rhombus, angles that are next to each other aren't necessarily congruent. Parallelograms, angles next to each other, aren't necessarily congruent, but if it was a square, if it fit into this category, it could be a rhombus, and it could have all four of the angles being right angles, making any two that are next to each other both right, so therefore congruent. So if it's a rhombus and also a square, this would be true. But it doesn't say that it's a square, it's just a rhombus. So we can't say never, we can't say always, we are going to have to say sometimes. And that's because it could be a square, but it might not be. So if it was a square, then those two would be congruent. Let's look at the next page. It says for any square, okay, CDEF, it's always or sometimes true that segment CD is congruent to segment DE. Explain your reasoning. So I'm going to draw a square, CDEF. Being a square, I know that opposite sides, or not all opposite, but all sides are congruent, and all angles are also congruent. They're all 90 degrees. So it says CD is congruent to DE. Well, by definition of a square, all my sides are congruent. So this is always true by definition of a square. All right, example 2 here says classify the special quadrilateral and explain your reasoning. So looking here, I know that I've got 4 angles that are congruent, or 4 sides, I should say, 4 sides that are congruent. With all 4 sides being congruent, we know it's a rhombus. Now this has a 127 degree angle, so it's not going to be a square. So our most specific thing is rhombus, and that's because all 4 sides are congruent. On your own too here. It says a quadrilateral has 4 congruent sides and 4 congruent angles. So let's put this up here. 4 congruent sides, 4 congruent angles. So these are all 4 the same. Classify the quadrilateral. Well, let's think here. If it's a quadrilateral, they all have to add up to, the angles all have to add up to 360. And if we divide that by 4, that's 90 degrees. So if all my angles are the same, they must all be 90 degrees, making them all right angles. So this would be a square. Nope, I don't want that. Here we go. Let's look at these last theorems. Theorem 811 says a parallelogram is a rhombus if and only if its diagonals are perpendicular. So we know a parallelogram is a rhombus if its diagonals are perpendicular. So that would mean segment AC in our picture here is perpendicular to segment BD. Theorem 812 says a parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. So here's the diagonal, and it bisects these and bisects this, so it cuts them in half. Here's the diagonal, it bisects this and bisects this, it cuts them in half. So that means it is a rhombus. So it says in our words here, our quadrilateral ABCD is a rhombus if and only if segment AC bisects angle DAB and angle BCD, and segment BD bisects angle ABC and angle CDA. Okay, so it's a rhombus if and only if our diagonals bisect opposite angles. Theorem 813 says a parallelogram is a rectangle if and only if its diagonals are congruent. So in order to be a rectangle, diagonals must be congruent. So quadrilateral ABCD is a rectangle if and only if, for our picture here, segment AC is congruent to segment BD. And let's look at the last page here. It says list the properties of special parallelograms. Example 3, sketch a rhombus, FGHJ to the right. Let's sketch a rhombus. Okay, list everything you know about it, and for it to be a rhombus, all these four have to be the same. So this is FGHJ. So I sketched it. So my figure is a rhombus. Well, what do we know about the angles? So for a rhombus, that means it's also a parallelogram. So opposite angles are congruent. That's one thing we know about the angles. Another thing that we know, because it's a rhombus, it's again also a parallelogram. Consecutive angles, let's use the angle sign, are supplementary. For the sides, what we know, since it's a rhombus, is that we have 4 congruent sides. And our diagonals, we know that they are perpendicular. For a rhombus, your diagonals are always going to be perpendicular. And we also know they bisect I'm just going to call them the corners of the rhombus. So these are the things that we know are true about the angles, sides, and diagonals simply because it's a rhombus. The next one here says sketch a rectangle, WXYZ to the right. List everything you know about it. Okay, so here's a rectangle. So this is W, X, Y, Z. Since it's a rectangle, my opposite sides are congruent. And so my opposite sides are congruent, and I know I'm going to have 4 90-degree angles. So my figure is a rectangle. My angles, we've got 4 90-degree angles, or 4 right angles. For our sides, we know that opposite sides are congruent, and rectangles are always parallelogram, so we can say and parallel. We probably should have added that up above here for my sides for my rhombus. We know that those are also going to be parallel. Our diagonals, we know that they are going to bisect each other. And then we're going to also know that they are congruent. Okay, let's do a real world problem here. Okay, so it says example 4, you're building a frame for a painting. The measurements of the frame are as shown. So looking at this, we know our opposite sides are congruent. Got that much on here. A says the frame must be a rectangle. Given the measurements in the diagram, can you assume this is true? Well, in our diagram, all they tell us is the opposite sides are congruent. That doesn't make it a rectangle. We have to know that we have 4 90-degree angles. So can we assume it's true? No. We don't know about the angles. We don't know about the angles. We don't know that they're 90 degrees or not. B says, you measured the diagonals of the frame, They're about 25 6/10 inches. What can you conclude about the shape of that frame? Well, if you look up above here for a rectangle, our diagonals are congruent. And since this is saying they're pretty much congruent, well, then that means that, yes, since they're the same, the frame is a rectangle. So what can you conclude about the shape of the frame? It's a rectangle. Because our diagonals are congruent. Example, or on your own 4 says, suppose that diagonals of the frame are not congruent. Could the frame still be a rectangle? Well, no. They must be congruent to be a rectangle. So rectangles, your diagonals must be congruent. If your diagonals aren't congruent, then you know it's not a rectangle. So this is the end of this lesson. Please make sure if you have any questions, you ask me about them in class, and have a great day.